All right, so let's move on. Uh, let's talk about analyzing an ellipse. So the game here is you just take whatever information you're given. Maybe that's you're given a few points. Maybe that's you're given the general equation. And you draw a quick graph. You find the vertices, foci, and center, and minor vertices, and draw a quick graph. You use your graph to find the A and B values in this case. So remember, the drawing is going to differ depending on whether your ellipse is longer in the horizontal direction, has a major axis in the horizontal direction, or whether it has the major axis in the vertical direction. If it were longer in the vertical direction, your picture would look more like this. Yeah, because if your ellipse is more long in the vertical direction, you're going to start with your center down here, and then since your ellipse is longer in the vertical direction, your focus would be up here. So this would be distance C. And remember, we always use, or at least I always use, A as the distance to the vertex in the X direction. But in this case, since it's shorter, it's a minor vertex. And so what is the remaining distance? B. And I have it written above as distance to the major vertex, but yeah, B would be the vertical distance, which is actually would be a little bit longer here to get up to that vertical major vertex in the vertical direction. So I was just going to draw the pictures to find whatever values you need. Once you find your A and B, then you can go ahead. You'll know the center. You'll figured all this stuff out. You can just put it into the correct format and then answer any questions you're asked. That's really the game. Again, always caution when you're solving these triangle pictures because it's a relabeling, non-traditional labeling of the Pythagorean theorem. So just be a little bit careful. So here's an example. Let's say all the information we're given is this, and they're basically like, give me all the info you can and graph this thing. Okay, well, let's just start. First things first, we're going to draw a quick graph. Our quick graph is just going to be plot the given information. I like to put a little hat over my C when talking about the center because C is the distance to the center of the focus. So I don't want to have two different C's floating around. So C for the center, C hat here. Focus 1, 2, 3, 0. So it looks like this tells us that we have a horizontal. It's longer in the horizontal. It's got the major axis in the horizontal direction. And then a vertex at 4, 0. You know what, I'm going to go ahead and change this. I'm going to make this negative 4, 0. So what if this was negative 4, 0? That would be 1, 2, 3, 4. Negative 4, 0. So here would be my vertex, and here would be a focus. And this is my major. We're longer in the X direction. I made that change because if the vertex was over here, you would necessarily know that the vertex is on the other side of the focus. But I just wanted to make a little change. Okay, so what do we know? What can we come up with from this? Well, the foci and the vertices are symmetric around the center. There's the same distance from the center. So the other focus, well, the focus we have is 1, 2, 3 units from the center. So our C value, the distance from the center to the focus, is 3. And so we'll go 3 in the other direction and land at our second focus. Might as well write it down, negative 3, 0. Identifying stuff as we go. And again, our distance here is C equals 3. I think I said 3 and wrote 1. Okay, well, we've got one vertex. Again, vertices are symmetric around the center. So if one vertex is 4 to the left of the center, then the other vertex is 4 to the right of the center. And since we're centered at 0, 0 here, those are pretty easy to count out. Now, notably, they have not given us any of the minor vertices or the B information to find it. So we're going to have to calculate B. Okay, so what do we know? We need A, B, and C. Well, we know A because we know the distance from the center to the major vertex. A equals 4 in either direction. So our triangle is going to be, and this picture will not be accurate, but keep in mind the triangle is going to have the base as the distance between the vertex and the focus. The vertical is going to be the distance between the vertex and wherever our minor vertex lands. And then this distance, we'll label that guy B. This distance is that A value, the distance from the center to the major vertex. Okay, so we've got our triangle drawn. We can solve that thing for b. B is going to be equal to, as we have it written here, the hypotenuse 4 squared minus the adjacent side there of 3 squared. 4 squared minus 3 squared gives us 16 minus 9, gives us square root of 5, which is about 2.24. Okay, and let's make a go for that. Okay, 2.24. All right, so let's take all of this information and let's try to draw ourselves a reasonably accurate graph. Yeah. Okay. Towards that end, we will redraw our thing because it's too cluttered up. We'll put our foci on there. Our foci are at negative 3, 0, positive 3, 0. Foci. Vertices at 4, 0, and negative 4, 0, major vertices on the long axis. And then our b value, since we calculated it on the other page, was root 5, which is approximately 2.24. So we're going to go from our center at 0, 0, which we'll put in 2.24 up, 1, 2.24, a little above 2 there, and a little below 2 in the negative direction. And there we are. So now you have enough information to draw a reasonably accurate ellipse here. And from there, we can just look at our picture and start identifying the key points. I'm going to do all the easy ones and then do the hard ones. Well, the center is provided 0, 0, and that one's easy to pick out. So are the foci. The foci at negative 3, 0, and 3, 0, those are just reading points off of the thing. So are the major vertices on the major axis, the horizontal axis there. The major vertices are going to be negative 4, 0, and 4, 0, respectively. And then our minor vertices. Well, what was this distance? That distance was that b value of root 5, which is approximately 2.8. So I'm going to write them in both the exact format and the approximate format. So for the exact format, the upper vertex will be root 5, 0, and the lower vertex, nope, not like that, because those are y values. It would be 0, root 5, and 0, negative root 5 for the lower one, which relate to 0, 2.24 as an approximation, and 0, negative 2.24 as the other approximation, respectively. Last but not least, major and minor axes. Well, the center's at 0, 0, so y equals 0 for the x-axis, and x equals 0 for the y-axis. We also are stating our b values. I don't know why I have b equals 3 here, because that is not true at all. B is not 3. B is equal to root 5. Okay, so let's now use this information to come up with the equation. Well, the equation is x minus the x coordinate of the center, x minus 0, squared over a squared, well, a is 4 squared, plus y minus the y center coordinate, which is also 0 since it's the origin, over b squared, so root 5 squared equals 1. Simplifying this, we come up with x squared over 16 plus y squared over 5 equals 1 as the equation for this ellipse.